let's talk about sequences, specifically arithmetic and geometric sequences. Now, before we get into that, let's talk about first what a sequence is. Well, let me give you first an example of it. 3, 5, 1, 17, negative 2, 3. A sequence is essentially a string of numbers in a specific set. Now, this string of numbers doesn't have to have a particular pattern, but for arithmetic and geometric sequences, they do. Arithmetic sequences are based off of addition and subtraction, where geometric sequences are based off of multiplication and division. But to dive into it a little bit more, let's first look at arithmetic sequences. Now, let's first give an example of an arithmetic sequence. 1, 3, 5, 7, 9. Now, if you happen to notice, there is a bit of a pattern there, so let's look into it. Let's take the second number, 3, and subtract the first number from it, 1. So 3 minus 1 is 2. The difference between the first and second one is an addition of 2. Or to get to the second one from the first one, you add 2. Let's do the same thing for the third and second numbers. So the third number is 5 and the second number is 3. 5 minus 3 is, again, 2. So that means that you add 2 to 3 to get 5. What you find is for every consecutive set of numbers, you add a number to the first one to get to the second number, and you add that same number from the second to the third, and so on and so forth. This constant number in the example that I just gave, the number 2, is called common difference, or what you add. Basically, in layman terms, it's what you add to the first number to get the second number, what you add to the second number to get to the third number, and so on and so forth. Now, this number can be positive or negative. So in the example I gave, the number was positive 2, because you start off with 1, you add a positive 2 to it to get 3. Now, in another set of sequence, in another arithmetic sequence, say 9, 7, 5, 3, 1, the difference between 7 and 9, the second and first numbers again, is negative 2. And you find that the difference between the numbers is always negative 2. So what happens is, in that sequence, in that arithmetic sequence, the common number that you add to it is actually negative 2. Or you subtract 2 with the addition and subtraction we were talking about earlier. This has been talking more in terms of intuition, what you can generally grasp from a series that you're given. But what if you're only given 2 numbers, say the first number in the sequence and the 5th number in the sequence, in the arithmetic sequence, and you're asked to find the 10th number? You need to somehow figure out the difference without really having the full series with you, the full sequence with you. And so you might need to turn to the more algebraic method, the more mathematical method. And what you do is you use an equation. So you do say that a sub n, which means that the nth term in your series is going to equal the first number in your series, which is whatever it is, plus the difference, which is a number you don't necessarily know, times n minus 1, where n is, again, the number we were just talking about. So what it basically means is to get from here to here, or rather, let's do it from your side. In order to get from here to here, you're going to want to add a number, whether it's positive or negative, a certain amount of times, based off of which number in the sequence this is. If this is the 4th number in the sequence and this is the first number, you need to add the difference 1, 2, 3 times, one less time than the number in the sequence that it is. Now, this can be used to find what the difference in your arithmetic sequence is, and you can then use that number to find out what some further number is going to be. But that's very math heavy. So that basically what this means is that there's 2 different ways to evaluate and figure out stuff from a given arithmetic sequence. You can just look at what there is in front of you and see visually between any 2 numbers what the common difference is. Or you could do the more mathematical way in order to find out what the common difference is and what future numbers will be in the sequence without needing to have the entire sequence there. Now let's look at geometric sequences. In a geometric sequence, let's first give you a geometric sequence. Let's say 1, 2, 4, 8, 16. Now, let's do the same thing as we did before. Let's take the second number and subtract the first number, in this case, 2 minus 1. 2 minus 1 is 1. So, now you go to the third and second number, which is 4 and 2. 4 minus 2 is 2. Now, what you can see is that 2 and 1 are not the same, meaning that this can't be an arithmetic sequence. But instead, what you can do is look at the ratio between the numbers. So in order to see if something is a geometric sequence, what you do is you take the second and first number and you do the second number divided by the first number. 2 divided by 1 ends up being 2. Now let's look at the third and second number, and rather than doing a subtraction, let's do a division, just like we did with the second and first number that we just did. So 4 divided by 2 is 2 again. What we find is that there is some common ratio, some common number that's multiplied to the first one to get the second number to get the third number, and so on and so forth. And in our example, that number is 2. That is the ratio of our geometric sequence. Now, the ratio doesn't have to be a whole number too. It could be a fraction, 5 over 3. It can be an even smaller fraction, just like 1 over 10. Really, all that matters is that it is some number multiplied to the first number to get a second number, and second to get the third, and so on and so forth. Now, again, that's looking at it from a more intuitive perspective. There is, just like with the arithmetic sequence, a mathematical way to figure out what the ratio is. And the way you can do that is by using the equation a sub n, which is the nth term in a series, is equal to a sub 1, which is the first number in the series, times the ratio to the power of n minus 1, where the ratio is that number that we found earlier that's common, the common thing you multiply to each one, and the n minus 1 is the same n from before, the nth term that you're looking for. So let's say you are given the first term, the third term, and you want to find the fifth term. So what you would do is you would set a sub 1 to be your first term, a sub n to be your third term, your ratio you don't know yet, and your n is number 3. So what you would do is a sub 1 times r to the power of 3 minus 1 is 2 is going to give you your third term. And then once you find what r is, you can then figure out what your fifth term is. So there you have it, arithmetic and geometric sequences. Arithmetic sequence has to do with addition and subtraction to find the common difference between your numbers in your arithmetic sequence. And in your geometric sequence, you have a ratio to look for that uses multiplication and division in order to find what the ratio is between your first, second, third, and so on number in your geometric sequence. Thanks so much for watching. If you have any questions about arithmetic or geometric sequences or sequences in general, feel free to leave them down in the comments below. And thank you so much for watching.